Assalamualaikum and hi. In this video, I'll talk about conditional probability and the multiplication rule. A conditional probability is the probability that an event occurring given that another event has already occurred. It's denoted by this symbol and is read as probability of B given A. Let's look at example 1. Table below shows the results of a study in which researchers examine a child's IQ and the presence of a specific gene in the child. Find the probability that a child does not have the gene. Okay, does not have the gene is referring to basically this column. Okay, so let's rename the column. Okay, let's say this is column G, and let's denote this as column G bar. Okay, so the first question is referring to the probability of G bar, and that is simply 30 over the grand total 102, and that's 0.294. And then in the next question, find the probability that a child has a high IQ given that the child has the gene. Okay, to answer that, let's rename this row as Q. Okay, for high IQ we put Q, and for normal IQ we write normal and Q. Okay, or maybe HQ and normal Q. Okay, so for second question is looking for probability of has high IQ given that, okay, given that the child has the gene. Okay, so the conditional probability is denoted by this formula. Okay, the intersection over probability that has happened, which is has the gene. Okay, so let's look at the denominator. The nominator, the upper part here. Okay, let's look at where is the intersection of high IQ and G. This is the one. Okay, 33 over 102. Okay, because as you can see, we have the symbol probability, so it must be 33 over 102, and then over. Now let's look at the denominator, P of G. P of G is referring to this column, which is P of G means 72 over 102, and this is actually 33 over 72, and that's 0.458. Okay, what about for the third question? You try on your own. Okay, I will provide only the final answer. Okay, do question 3 on your own and then check the answer and make sure you get 0.367. Okay, now in example 2 is about a person owns a collection of 30 CDs, of which 5 are country music. That means the remaining 25 CDs are non-country music. Okay? Okay, and then in example 2, you can see this new term with replacement and without replacement. Okay, so usually or intuitively, you should think of drawing a tree diagram to solve this question. Okay, I will draw the first tree diagram. Okay, for question A. Okay, basically, 2 CDs are selected at random and with replacement. Okay, I will explain about with replacement. Okay, find the probability that the second CD is country music, given that the first CD is country music. Okay, so let's do the tree diagram first. Okay, so you will choose 2 CDs. Okay, so this is the first CD, and then second CD. So basically, you will have 2 level of branches in your tree diagram. Okay, so for the first CD, it will be either country music or non-country music. So we will denote non-country music for CM bar. Okay, and then for second CD, the same thing. You will get either country music or non-country. Okay, the same thing here. Country music and non-country music. Okay, but in order to answer the next the question in the next statement, find the probability. Okay, in order to find the probability, you must know the value for each branch. Okay, that means what is the value of the probability here, here, okay, and for each branch. Okay, here. Okay, basically we need to figure out 6 probability values. Okay, so bear in mind this selection is done with replacement. Okay, so during the first CD selection, the probability of choosing country music will be 5/30, because you have 5 CDs which are country music, and then you have 25 non-country music CDs. Okay, and since we are talking about probability, you must write 25/30. Okay, and then during second selection, since the selection is done with replacement, so during second selection, we still have 30 CDs. Okay, we still have 30 CDs during each selection. Okay, so this will remain the same. 5, 25, 5, 25. Okay, and then another feature that you need to have in your tree diagram is to list the outcome. Okay, you can simply write this way, CM, CM. That means both CDs are country music, or this one, the first CD is country music, second CD is non-country music, and then we have non-country music for the first CD and country music for the second CD, and finally both CDs are non-country music. Okay, what is the question now? Find the probability that the second CD is country music. So to denote that, we write CM2. Okay, this is CM1. Okay, I mean to to the small 2 is to denote this is during second selection. Okay, given that the first CD is country music. So this is actually referring to, since the formula is actually probability of the intersection, okay, over probability that the first CD is country music. Okay, and this is, okay, probability of CM2 intersect CM1 is this. Okay, M30 times M30. Okay, M30 times M30. Okay, I'm done for the top part. Over probability of choosing country music. Okay, which is 5/30 for the bottom part here. Okay, and as you can see, we can actually cancel out 5/30 and left with 5/30, and that's 0.167. Okay, now let's continue with the second question. This time, the selection made is without replacement. Find the probability that the second country music, given that the first CD is country music. Okay, so let's use the same tree diagram. Okay, basically the tree diagram will be the same. The difference will only be on the probability value. Okay, let's see. Okay, so now let's look at this one first. Okay, the selection is made without replacement. Okay, that means, as you can see, the first CD is country music. That means during second selection, we are left with not 5 but 4 country music CD, and also the subtotal here is not 30 but 29. Okay, so the probability value here will be 4/29. Okay, what about this one? Okay, since during the first CD we haven't picked a non-country music, so it will still have 25 CD of non-country music, but the overall CDs is 29 because the selection is done without replacement. Okay, so that means we are not putting back the first CD into the box. Okay, now let's look at this one. Okay, the first selection is non-country music. So that means during second selection, we are left with 24 non-country music over 29. Okay, the same thing here. Since we haven't choose country music, so we still have 5, but the overall is 29. Okay, so as you can see, the probability value change to different values. Okay, so for B, the question is basically the same as A, but the probability value is changed. What is the probability that the second CD is country music, given that the first CD is country music? Okay, following the formula is to find the probability of the intersection over probability of CM1. Okay, so this is CM2 and CM1, okay, will be 5/30 times 4/29. Okay, over probability of CM1. This is 5/30, and we can actually cancel out this, and we are left with 4/29, and that 0.138. Okay, can you compare the value that you get from A and the value that you get from B? Okay, when the selection is done without replacement, the probability value drops, right? Because we have less number of CDs. Okay, so that's the end for example 2. Okay, now let's look at independent and dependent event. In some experiments, one event does not affect the probability of another event. Okay, example, when you roll a die and toss a coin, the outcome of the roll, the outcome of rolling the die does not affect the probability of the coin landing on heads or tail. Okay, so basically these two events are independent. Okay, awak boleh juga fikir contoh lain. Contohnya awak kata, saya pakai baju merah, saya makan aiskrim. Benda tu adalah obviously that's independent event. Sebab pakai baju merah dengan makan aiskrim tak ada kaitan pun. Okay, tapi kalau awak kata, saya rajin belajar, saya dapat A. Mungkin itu adalah dependent event. Okay, sebab mungkin juga sebabnya awak dapat A sebab awak memang rajin belajar. Jadi itu adalah dependent, kan? Okay, we can use conditional probabilities to determine whether events are independent or not. Okay, two events are independent if the occurrence of one of the events does not affect the probability of the occurrence of another event. Okay, events that are not independent are dependent. Okay, nanti kita tengok formula. Okay, classify whether the events are independent or dependent. Okay, well, for these examples, basically it's very intuitive. Awak teka sahaja. Maksudnya awak tengok condition yang diberi dan awak agak-agak sahaja. Okay, sebab kita belum melibatkan sebarang pengiraan lah. Okay, tengok contoh yang pertama. Tossing a coin and getting a head, and then rolling a die and obtaining a 6. Okay, adakah event A dan B independent atau dependent? Okay, obviously ini adalah independent lah. Dia tak bergantung pun antara satu sama lain. Selecting a king from a standard deck, not replacing it, and then selecting a queen from the deck. Well, I'm not sure about this because I'm not good with card. Can I proceed to the next one? Driving over 135 km per hour and then getting in a car accident. Well, this might be dependent. Awak bawa laju dan awak terlibat dengan kemalangan. Itu most probably adalah dependent. Smoking a pack of cigarettes per day and developing emphysema, a chronic lung disease. Okay, so be careful for those smokers. Okay, these are dependent events. Exercising frequently and having a 4.0 grade point average. Well, maybe when you have a fit body, you might be able to perform well in your studies, right? So I would say this is dependent. Okay, kalau awak lemau je, mungkinlah awak tak dapatlah nak perform well in your studies, right? Okay, untuk soalan kedua ni saya hold dulu sebab saya pun tak reti sangat. Tak berapa boleh nak bayang yang ni. Okay, kalau awak ada idea, awak boleh share dengan saya. Okay, independent and dependent events by looking from the perspective of the conditional probability. Okay, two events are independent if probability of B given A is exactly the same as probability of B. Maksudnya apa ni? Maksudnya event A tak mempengaruhi pun event B. Atau yang ni pun sebenarnya sama sahaja ya, cuma cara penulisan saja. Probability of A given B is the same as probability of A. Maksudnya B tidak mempengaruhi A. Okay, to determine whether A and B are independent, calculate the probability of event B, calculate the probability of B given A. Okay, if the values are equal, the events are independent. If the values are not equal, then A and B are dependent events. Well, let's see by example. A random sample of 400 college students was asked if college athletes should be paid. The following table gives a two-way classification of the responses. A student is selected at random. Are the events that the student is athlete and the response is should be paid independent? Okay, first of all, it's already given to you in simplified form. Okay, so for student athlete, it's denoted by SA. Non-student athlete and student which is non-athlete, S and A, okay, should be paid and should not be paid is denoted by paid bar. Okay. This is the question. The events that the student is athlete. Okay, event A adalah student is athlete, SA lah. Okay, ini event A. Event A. Okay, event B adalah should be paid. Maksudnya PAID ni lah. Okay, without the bar. Okay, jadi kita nak tahu, kita kena cari probability of SA over PAID. Kita cari yang ni dulu, satu persatu. Okay, kita cari yang ni dulu. Yang ni step pertama. Okay, jadi kita buat. Ini kalau kita ikut formula adalah PSA intersection PAID over probability of paid. Kan? Kita ikut je formula conditional tu. Okay, SA and paid. Mana intersection dia? Yang ni. 90 per 400. Okay, kita sentiasa per dengan grand total. Okay, apa dia probability of paid? Probability of paid adalah 300 per 400. Dan ini sebenarnya adalah 90 per 300 lah. Okay, guna kalkulator. 0.3. Okay, yang ni kita dapat untuk sebelah kiri. Okay, sekarang kita nak tunjuk apa dia P of SA. Okay, P of SA, apa dia? P of SA adalah 100 per 300. Dan ini adalah 0.333. Okey, kalau kita tengok tak sama kan? Sebab ini exactly 0.3. Dan ini adalah 0.333. Tak sama, memang tak sama. Okey, maksudnya apa? Kita buat kesimpulan kat sini. Probability of SA given paid tak sama dengan probability of SA. Maksudnya Dua event ni adalah bila tak sama, maksudnya dia adalah dependent. Okay. Okay, kalau awak nak cuba sendiri set lagi, awak buat pengiraan lain pula. Awak cuba tunjukkan is probability of paid given as A sama tak dengan silap, tak payah tulis macam ni. Sama tak dengan probability of paid. Kalau awak dapat sama, sepatutnya dapat tak sama lah. Sepatutnya dapat tak sama. Baru jawapan dia akan selari dengan yang ni. Okay, sepatutnya dapat tak sama. Sebab ni persoalan. Is probability of paid given as A equals probability of paid. Okay, I'm expecting the answer should be not equal. Okay, sebab kita dah tunjuk dekat sini, the two events are dependent. Okay, I think I'll stop here for today. So basically, we are done with conditional probability. We have mentioned about experimenting with replacement and without replacement. Okay, dan saya nak awak lukis balik tree diagram yang CD tu tadi properly. Kan, sebab saya ruang tu tak cukup, jadi saya conteng balik atas tree diagram yang sama, jadi it's not really proper. Okay, cuba buat balik yang tu. Saya dah explain dah dekat slide tu sebenarnya, cuma saya takut tak nampak bila saya tindan tulis tu. Okay, that's all for today. Thank you so much.